Good morning, class, and welcome to this lesson on Circuit 6 Ohm's Law. Today, we will be able to describe the relationship between current, voltage, and resistance. Okay, we've already gone over a little bit what current and voltage is, so let's talk about what resistance is. And resistance is defined as the ratio of voltage over current. So it is the ratio of the voltage applied across a piece of material to the current through the material. So resistance, R, is really equal to V over I. So so the units for resistance are volts per amp. But resistance has its own unit, R, resistance, and so a volt per amp is equal to ohms. So this is the symbol, the Greek symbol omega, which is going to be the unit for resistance, resistance being a volt per an amp. Okay, and so we call this Ohm's law, and it is more commonly written as this: V equals I times R. Okay, so V equals I times R. As we can see here, actually let's go on for a second. Let's move to the next page real quick. So a good way of understanding this law is to think of circuits like a water line, okay? Circuits like a water line. In order for water to flow, it must have a pump. A pump literally pushes water through the line. So the pump actually is the pushing force that makes the water pump through the line. That's the same thing a battery does. A battery pumps charge through a circuit, okay? We have a valve in a water line that turns it on and off, kind of like a switch, okay? And then we have resistors, or things that the water has to flow through that might slow down its movement. So, if we have a stronger pump, we're going to have faster flowing water. Okay? So if we have a stronger pump, we have more current. If we have a stronger pump, we have more current. So if V goes up, then I goes up. Okay, so V and I are directly related. V equals I times R. On the same token, the stronger we pump the water, the more water we try to force through there, the more this line here, or the resistor, will try to resist the flow. So current and resistance are directly opposite. Current is the flow of charge. So current is the flow of charge. And resistance literally is the resistance of charge, okay? I know using the same word in definition isn't that good. So resistance resists flow. So these two are inversely related. So if we look at it this way, R equals V over I, if resistance goes up, current goes down. So now we know how these are all related. If voltage goes up, current goes up. If voltage goes up, resistance goes up, because the more it's trying to push it, the more it's going to try to resist it. And on the same token, if current goes up, then resistance goes down, or if resistance goes up, current goes down, because those two are literally, by definition, opposite, because current is the flow of charge and resistance is the resistance to flow. Okay, so that is summarized in our equation: V equals I times R, which is Ohm's law, resistance being measured in ohms, which is where we use the Greek symbol omega for. And so, just as a side note, here are some common resistors that we see in circuits, and these banded lines you see here, these colored lines, they basically tell us what resistance this has. Like this could be a 1 ohm resistor. This black one could be a 10 ohm resistor. I actually don't know. I could be totally off on that. But the colors and the bands tell us what kind of resistor they are. But I also want to make the same point again. Any device is a resistor. Any device is a resistor. Okay? A lamp or a light bulb. Okay? Is a resistor. Okay, a buzzer is a resistor. A alarm is a resistor. Anything we power up is a resistor. If you're playing a video game and you have batteries in your remote control, the remote control itself is a resistor. It is a device. So it doesn't matter what it is. Any device is a resistor. So when we see this symbol, in a circuit symbol, it really can be anything, and that will be defined by the question that's being asked.